Okay, in this lesson, we're going to talk about yet another way of solving a system of equations, and that is with Cramer's rule. Now, before we start Cramer's rule, we first need to talk about what a coefficient matrix is. Reminder that coefficients are the numbers in front of your x and y values. So what we're going to do is we're going to take our x and y's here, and we're going to make a matrix out of just our coefficients. So that'd be 1, -5, -7, and +2. That would be your coefficient matrix. And then now let's use this to actually solve some systems. It says Cramer's rule, which is named after Swiss mathematician Gabriel Cramer, uses the coefficient matrix and determinants to solve a system of linear equations. So we're going to start out with a two-variable system. Given this system of equations, we're going to let matrix A be our coefficient matrix, A, B, C, D. And then as long as the determinant of A, as long as it is not equal to 0, then the system is going to have a unique solution given by. Now, I do want to point out, here's how we're going to find it. To find our x value of our system, you've got the determinant of the coefficient matrix on bottom. And on top, you have the determinant of the coefficient matrix with one exception. The x columns has gotten replaced with these two numbers. And then to solve for y, you have the determinant of your coefficient matrix on bottom, but the y column on top has been replaced with these two numbers. So again, you're going to take out your A and C, and you're going to replace them with E and F. Here you're going to take out your B and D, and you're going to replace them with E and F. Note the determinant of the coefficient matrix, if it equals 0, then the system does not have a unique solution. It has either no solution or infinite solutions if the determinant is equal to 0. So example 1, let's go ahead and say matrix A is equal to our coefficient matrix, 1, -5, -7, and 2. And if you'd like to, we can go ahead and find that determinant. The determinant of A is equal to down minus up, so 2 minus 35 or -33. That's your determinant. So now your x value, the solution, is going to equal the determinant on top of, okay, here's what you do. Once again, you take out the x column and you replace it with these two numbers, 9 and -30, and then these two stay the same, -5 and 2. And you've already done the bottom. The determinant of matrix A was -33. So the top is down minus up is 18, minus up is 150. 18 minus 150 is -132 over -33, which is 4. That's the value of x. Next up, the value of y. You do the determinant of, we're going to take out the y column now, leave the x the same, and you're going to replace the y column with, again, your whatever's to the right of the equal sign over here. And then on the bottom, again, we have -33, which was the determinant of A. So on top, you now have down minus up is -30 minus -63. That'd be plus. -30 plus 63 is 33 over -33, which gives you -1. So therefore, x is 4, y is -1. There's your solution. Okay, the second one. Now that you've seen that, I'm going to work the second one a little bit different. Your x value is going to equal, and I'm just going to write this out. On bottom, the determinant of your coefficient matrix, which is 2, 6, 5, 1. On top, the y stuff stays the same. The y column stays the same, but the x is replaced with 38 and -3. To find your y value, again, the bottom is the determinant of your coefficient matrix, 2, 6, 5, 1. The top, the x column stays the same, but your y column is replaced with 38 and -3. Find your determinants and you're done. On top, down minus up will be 38 minus -18, which would be 38 plus 18, which is 56. The bottom is 2 minus 30, which is -28. Final answer for x is -2. We can already put our -28 on bottom over here. The bottoms will be the same. The top is going to be -6 minus 5 times 38, which is 190. and that gives you on top negative 196. Negative 196 divided by 28 is 7. So therefore, x is negative 2, y is 7. There's your solution. Example number 3. Your x value will equal the determinant on top, determinant on bottom. The bottom is your coefficient, which is 6, 1, negative 3, negative 2. On top, leave the y's the same, but replace the x's with negative 22 and 17. So let's work the bottom out to begin with. That's going to be negative 12 minus negative 3, which is negative 9. On top, you have 44 minus 17, which is 27. So therefore, your x value is negative 3. Your y value, the bottom is the same. So if you just want to put the negative 9 on the bottom, because that determinant is going to be the same. On top, your x column stays the same, negative 22 and 17, from your coefficient matrix. And then you replace the y column with negative 22. Well, hang on. Let's try that again. The x's stay the same, which was 6 and negative 3 on your coefficient. The y column turns into negative 22 and 17. On top, down minus up is going to give you 102 minus 66, which is 36, over negative 9, which is negative 4. So therefore, your point where these two cross are at negative 3, negative 4. Now, solving a system with 3 variables, very similar. Here's your coefficient matrix, or excuse me, here's your system, here's your coefficient matrix. As long as the determinant is not 0, then your system will have a unique solution. Notice the bottoms are still the determinant of the coefficient matrix, and you follow the exact same protocol we did before. To find x, you take out the x column and you replace it with these 3 numbers. To find y, you take out your y column and replace it with those 3 numbers, and the same thing to find z, you replace it, the 3rd column there. Therefore, let's go ahead and try one of these. Let's start with x. So x is going to equal to, let's start with the bottom. The bottom is going to be the determinant of your coefficient matrix, which is negative 1, 7, negative 2, 2, 1, 9, and 3, negative 5, 2. The top, your y and z columns stay the same, 7, 1, negative 5, negative 2, 9, and 2. Your x column is replaced with these 3 numbers, negative 14, 43, and 2. Now, I'm going to just do a couple of these, but just to remind you, how do I find the determinant of a 3 by 3 matrix? You recopy the first 2 columns, negative 1, 2, and 3, and 7, 1, and negative 5. And then you do your downs minus up. To do our downs, we're going to multiply these 3 numbers. That gives me negative 2. Multiply these 3 numbers, gives me 21 times 9 is 189. And then multiply these 3, and that gives me a positive 20. So my downs are equal to 207. And then I do my ups. Multiply these 3 gives me negative 6. Multiply these 3 gives me a positive 45. And these 3 give me a positive 28. 45, 28 is 73 minus 6 is 67. So down minus up, 207 minus 67 is equal to 140. We then do the exact same thing for the top. Recopy the first 2, negative 14, 43, and 2, 7, 1, and negative 5, and follow the exact same procedure. Let me erase this to give me some more room. We're going to do down minus up. First off, our downs, we're going to multiply these 3. That's a negative 28. Multiply these, that'll be 14 times 9, which is a positive 126. And multiply these, and that gives me a positive 430. That's your downs. Your ups are going to be a negative 4. This will be a positive 630. And this will be a positive 602. So downs is going to equal 528. Your ups are going to equal 1228. So down minus up gives me a negative 700. And when I divide negative 700 by 140, I get negative 5. So that's the process. So I'm not going to go through all those steps for each of these, but my y value is going to be the determinant on top over the determinant of a on bottom, which is 140. I've already done that. And again, on top, your first two columns stay the exact same thing as they did in the coefficient matrix. So as your x column, and here is your z column. The only difference is you replace your y column with these three numbers, negative 14, 43, and 2. That's going to give you an answer of negative 140 on the determinant on top, and a 140 was on bottom, so therefore my y value is negative 1. To find your z value, again, the bottom is going to be the same 140. However, the top, you take the first two columns from your coefficient matrix, which was negative 1, 2, 3, 7, 1, negative 5, and you replace your z column with negative 14, 43, and 2. When you work out the determinant on top, you get 840. And when you divide 840 by 140, that gives you a value of 6. So therefore, your x value is negative 5, your y value is negative 1, and your z value is 6. There is the solution to that system. Example number 5. To find your x value, I'm going to go ahead and do the bottom. The bottom is going to be the determinant of your coefficient matrix, which is 3, negative 1, positive 1, 1, 2, and negative 7, 5, negative 6, and negative 2. The top, the second and third columns remain the same. The only thing that changes is your x column. Your x column turns into these three numbers, negative 23, positive 63, and negative 14. When you work out these two determinants, you get 484 and negative 121. When you divide those, your x value is negative 4. To find your y value, the bottom stays the exact same, and we already know it's negative 121. The top, the only thing you change, you go back and you recopy your first and your third column from your coefficient matrix on bottom. The y column, however, changes to negative 23, 63, and negative 14. When you work out the determinant on top, you get negative 242. On bottom, you already had negative 121, so that gives you a y value of 2. And finally, again, your z value, the bottom is still negative 121. The top, you're going to take your x column and y column from your coefficient matrix, which was 3, 1, 5. Make sure you do it from your original coefficient matrix, negative 1, 2, and negative 6. Your z column is replaced with, again, these three numbers, negative 23, positive 63, and negative 14. When you find the determinant on top, you get 1,089. The bottom was negative 121, giving you a final z answer of negative 9. So therefore, the solution to this system is negative 4, positive 2, and negative 9. Example number 6. Doing the exact same thing. To find x, you're going to do the determinant of the coefficient matrix on bottom, which is going to be negative 1, 4, 1, 8, 3, negative 2, negative 2, negative 1, and 9. On top, again, you simply take out the x column, leave the other two the same. Take out the x column and replace it with these three numbers, negative 26, negative 19, and a positive 32. That's going to give you two determinants of negative 299 and negative 299. So my x value is 1. My y value, again, the bottom is going to be still that negative 299. The top, you take the exact same negative 1, 8, and negative 2. 1, negative 2, and 9, but we're going to replace our middle y column now with negative 26, negative 19, and a 32. Finding the determinant of the top gives you 2,093, and again, the bottom stays the same. So when you divide that, you're going to get a value of negative 7. Our Z answer. And now let's talk about another way. If you didn't want to do that 3 times, you do have another option. Since you do have an X and a Y, why not just come over here and take one of your equations and plug in that X and Y? That gives you negative 1 plus, or actually minus 28 plus Z is equal to negative 26. If you replace them in your first equation, negative 29 plus Z is negative 26. When you add 29, you get a Z value of 3. So once you have X and Y, you can use back substitution, and that's going to give you your solution. X is 1, Y is negative 7, and Z is 3. Something else that might speed this up is going ahead and finding your determinant for A. In this case, again, A is going to be 1, negative 1, negative 1, 4, negative 11, 2, negative 1, negative 7, and 9. And if you go ahead and find that determinant, it might go ahead and speed up your answers. In this case, the determinant of A is negative 8. So now we have X is going to be the determinant of, we're going to replace our X column with 9, 12, and negative 41. Our Y and Z columns stay the same, negative 1, negative 11, and negative 7, negative 1, 2, and 9. And we're going to divide that by negative 8. Our Y value is going to be the determinant of, everything stays the same except for our Y column, 1, 4, and negative 1. Our X column and our Z column stays the same. We replace the middle column with 9, 12, and negative 41. And again, the step a lot of people forget, don't forget to divide that by the determinant of A. And then Z is going to be the determinant of, leave your first 2 columns the same, 1, 4, negative 1, negative 1, negative 11, negative 7. Replace your Z column with 9, 12, and negative 41. And then divide your answer by the determinant of A, which was negative 8. Your X value is going to be negative 40 on top and negative 8 on bottom, which is 5. Your Y value is going to be actually 0 divided by negative 8, which is fine because the 0 is going to be the determinant on top, which gives you a value of Y of 0. And then Z is going to be 32 as the determinant on top over negative 8, which is negative 4. So your solution is 5, 0, negative 4. Okay, one more example, and I'm not going to work this all the way out, but I will give you the answers. The determinant of your coefficient matrix here would be 144. To find your X value, you're going to find the determinant of everything, replacing your X column with these, and that's going to give you a value of 864 on top, and of course your determinant of A is on bottom, and that's going to be a final answer of 6. Your Y value, the determinant on top, replacing your Y column with negative 50, negative 34, negative 6 gives you negative 288 over the 144. So final answer is negative 2. And then your Z answer, taking the determinant on top, will give you negative 1152 over the 144, which is negative 8. So your solution here will be 6, negative 2, negative 8.